The first exercise we're going to do is called optimal selection. We have three products, as you can see on the screen, product 0, 1, and 2, and their prices will change over the course of 8 days. What we want to do is to purchase each product once with the least amount of money. And what you see in gray are the actual answers. If you buy three products on those gray days, overall we can achieve the lowest, which is $5. So let's first establish the data structures. So price XD is the price of the product X on day D. So total of S and D represents the minimum total price of the subset of products by day D, right? So what's the minimum total price you have to pay for a selection of products by day D? And as you can see, this total has two parameters. So it's going to be a 2D array. So let's move on and go straight to the total table. We're going to have on the left hand side all the subsets. So the subsets that we're going to take a look at can be represented by the integers as we have seen in the bitmask example. So it'll be 0, 1, 2, 3, 4, 5, 6, 7. As the number of subsets we have over three products will be 2 to the power of 3, which is 8. So we're going to create a subset array to be the size 8. So we have these indices. Now, in terms of each bits on these subset, it gives you all the different subset combinations of the three products. Okay, we like to then calculate the total minimum price of each of these subsets over again the course of 8 days. So we're gonna have that. We'll actually have 7. Okay, so before we start, we can establish that if we are buying an empty set, the total price will always be 0, right? We're basically saying that the total for an empty set by any day is 0. What we can also establish is that if you are buying the single product on day 0, it'll basically be their first day price. So buying only product 0 by day 0 will simply equal to the actual price of that product on that day. So it'll be $6 for the product 0, $8, and $5. So these are the rows that are somewhat significant in that they represent a single product. Okay, buying more than one product will be impossible. So this will be some sort of infinity. We can say that the total of single product on day 0 equals the price for that product on day 0. So these are the two default values we can establish before we actually start performing the recurrence relations. So recurrence relations, let's look at this cell right here. So if you want to purchase product 0 by day 1, then you could either purchase it on the second on day 1 or have purchased it on day 0. So what we are looking at here for this value, it's 0 plus the price of product 0 on that day, or 6, whichever the one that's minimum. So the minimum here will be 6. So we're gonna just retain 6 on that day, like that. Now let's take a look at this value. So buying product 2, obviously you can retain that 8 or go to the 0 and then add the price of this product on day 1, which is 2. So the smaller of the two will simply be the 2. What's slightly more interesting is this value. So what that value represents is we have product 0 and 1. So we can either go here and add the price of product 1, or we can go here and add the price of product 0, right? So it'll be 6 plus 2 or 8 plus 9. So 6 plus 2 is obviously smaller, and that value is an 8. Okay, I'd like you to pause the video and work on the rest of these 4 numbers just to make sure that your understanding is correct. So pause the video right now and try to populate these 4 numbers into your own table. The answer to those 4 are 3. Purchasing all 3 products by day 1 is impossible. So again, that doesn't work. Just like that. On day 2, it's going to be 5. And you can actually use your own intuition to calculate this. So 5, because we only want the first one. So definitely just take that there. If you want to go to, if you want to have purchased only the second one, you'll retain 2. If you want the first 2 items, we'll go from 2 and add 5, right? So that'll be a 7, and then 3, 8, 7, and then finally 12. Okay, and then the rest will just use the program to generate. We want to establish the recurrence relation formula, and then you can simply translate that into your own code. So the total for any subset by day D will be minimum of 2 things. The first one is obviously not making any purchase on that day, so it'll simply be same as the value you had for the same subset by the previous day. But what if you're buying one of those items? So for example, for this 111, so for every item within that subset, we want to look at the total of the previous day of everything except for the item that we are purchasing, and we'll add the price of that item on day D. We'll have to do this again for every single product X within that set and take the minimum. Okay, so this is the recurrence relation. So you're gonna need a for loop. I hope this makes sense to you. I hope this table makes sense to you. And this is just the translation of what we did on the table. Okay, so try programming this on your own. Give yourself about 20 minutes and then come back and check my code.